No doubt, no one has heard of the light year unit, this unit, which astronomers use to measure distances in space, and we can look at as the older brother of units such as cm, km. In summary, although the distance that a bunch of light completes in a year 10 trillion km, it is very important to understand this unit of measurement well in order to follow astronomy. Let's start with an example from everyday life. You're meeting your friends, but you're a little late. Call them and tell them you're 10 minutes away, for example. This is an estimate to travel the remaining distance on your part. In astronauts, they estimate the distance to stars and galaxies in the same way, but instead of their own walking and driving speeds, they take a beam of light as a reference. The first reason for using this method is, of course, the equal speed that light has throughout the universe, 1,078,000,000 kilometers per hour. Traveling at this speed means taking 8 laps around the world in 1 second. Really impressive, huh? You may think that when you set off from Earth at the speed of light, you will travel a long distance in the same time period, but you must not forget the width of space. Even to reach the moon, you need a 2.5 second journey at the speed of light. The journey to the sun at the speed of light takes about 8 minutes. Can you believe it? Even at the speed of light, where you are traveling at a distance of about 300,000 kilometers per second, 8 minutes can only get you to the center of our solar system. Despite the incredible speed the light has, the journey time it needs has always been a side effect. The best example is that when we look at the sun, we're actually looking at it 8 minutes ago. Actually, we can give many familiar examples of this situation. We know we see explosions and fireworks, but the sound comes later. If we close our eyes, we'll witness the show a few seconds behind. The same goes for light. We see that there is an event only when the light reaches us. Looking at one end of the room, although the delay is a few billionths of a second, at large enough distances, the light suddenly replaces the sound in the fireworks sample. However, the main reason we use the light year is because of the enormous distances we are intertwined in space. If we insist on sticking to the mileage, even when we try to calculate the distance to the nearest star, we struggle with long numbers. The dim Crimean dwarf Proxima Centauri is 38,600,000,000,000 kilometers away. Using a long bar, that is, a larger unit of measurement, makes the numbers more controllable. For an astronaut, Proxima Centauri is only 4 light-years away. In other words, it takes 4 years for the light in the star next door to us to come to us. The distance from one end of our Milky Way galaxy, home to the stars we see when we look at the night sky, to the other is 100,000 light-years. If we consider this in another perspective, recorded human history is sketchy 5,000 years. Recorded